Now let's move to the visualization of MATLAB. MATLAB has a strong library to visualize the data, not only by 1D, but also by 2D. And the script is quite straightforward to use. So the following part has got one example to visualize trigonometric equations here. So again, let's just copy and paste them into a new script file and then later on look at it. So copy, new files, and to have a good habit, we always try to put a clear all at the very beginning to make sure that the new calculation would not be affected by the previous calculations. So previously it was stopped by a debugging process somewhere in the middle. So we just stop it and then save this file here to be able to run it. So let's say this one could be called plotting.m, right? So it's ready to go. So as you can see, when we run this program, there will be two graphs popping out. So one graph is here. The second one is coming up where the status is shown busy. So now busy is completed. So there are two graphs displayed here. One is only one plot here and the second is that one. So I'll show you how those things is being done in the script. So first of all, everything is being cleared. Then we create an array. It starts from 1, finish at 12 with an interval of 0.1. So that would be 1, 1.1, 1.2, 1.3 up to 1190 and then 12. And basically y1 here is cosine x, and you see that this is pretty convenient. X is an array, and after using the internal cosine function, we produce a y1 that is also the 1 times 111 cells, same as the input, and that's basically the y produced. And y2 is the sine, and then y3 has a bit phase shift, so it's the -1. Once we've got all the data, it's ready for us to visualize the result. So to be able to do so, the first thing is actually create an empty plotting area like this, right? So that's basically the empty plotting area. So we could move this one to give a bit more space for the graph. And that's basically the empty graph here. So the plotting is being done by the command here. So it's plot. We just try to put it in for now, and then I'll show you what really happens. So once I put this command and then press enter, we end up with a line looking like that. So the line is red with a lot of crossings, and the line width is relatively thick, and the line width is, so everything is being given here. So what does it mean here is that plot is basically the function to make a plotting. X here is the x-axis. The y1 is basically the output. So we are talking about using a cosine function. So y1 is displayed here. Now this is a little bit tricky. So this part actually shows what the line look like. So here it's actually red, which is the reason why it's the red color. Minus, which means it's a continuous line. And X here is actually the shape of those dots here, right? So basically this one shows you that red line with X dot at the location where the data is located. Then we use comma to separate it. This comes with a CSV format. So line width, if you put a keyword line width quoted, that means the value immediately after them is about the width of the line, and that line here is 2. So the same thing happens here. Display name cosine x. So the display name is the name that will be appeared when you draw a legend. The legend is actually given once all the plotting is being done. So if you show that later on, the cosine x will be displayed. So the tricky thing really is to understand what does this part mean, right? Then we can show a few other things, and I'll explain later on. So once we run this part, we need to put a function called hold on. What does the hold on mean is that after you plot this line here, stop erasing the existing graph and try to plot another one immediately on top. So if I don't put hold on, what will happen is that when we plot this line here, the previous thing will be erased. You see the previous line is not there, and this is not what you are expecting. So to be able to move back to the previous condition, we can just do the plotting again, because hold on is not there. They will wipe off all the things had before. So we go back here. So we again put a hold on, and that will hold it, and then we can do another one plus a hold on at the end of the line. The other interesting thing you can see here is that I basically have got two lines of script in one line separated by a semicolon. Yes, you can do so, and it's actually a good way to make your line relatively neat if they basically follow the same pattern. So the other way would simply be like this, but this doesn't look as good as you put both commands in one line here, right? So let's do the second one here, and you will find that the result has got two lines overlapping each other. So the reason the second one is a little bit different, particularly the shape and lines, is because the B here identifies the line is blue. The double dot here shows that the line is actually a dotted lines. So it's not that clear, but you can clearly see it's actually break lines. The V here is telling you the shape is actually a triangle, a reverse the triangle here. So the line width is 3, which is slightly thicker than the previous line. And we can keep going. So let's do another one here. Hold on. And what you will see is that it comes up with a third line. And the property is that it's green. And the line dot here means it's actually dash dotted line. So it's a dash line, a dot, and that followed by a dash and dot. The O here is basically the shapes. So let's say if you don't want to have shapes, you could simply do that, and then it wouldn't have a shape. It's just the dotted line. Or let's say if you don't want to have the lines, you can just simply do that, and still you'll be able to get the same result. So we can try that here. So let's say we remove all the shapes and just copy and paste this bit of lines. When what we will see is that it's only the lines without all the shapes we have defined before. So that's basically the way you can play with it. The other way you can play with it is actually an interactive plot. So after you have run this, you'll be able to use the cursor, say edit plot, and you could simply double click the line you want to edit. Then it will come into an interactive plotting area where you can change the line type to different thing. You could also change the shape in different ways. So once we do that, it will change immediately, right? So that's the way to do the interactive plotting. And you could save the figure to a FIG file. So I can call it my first plot. And it will save it to the working directory, which is here. Right, so if next time you close this plotting area, you could still double click this to be able to see the previous result, which is quite convenient. We will further look at the function interactive functionality, but let's just try to finish all the lines here. So later on, we could do the X label and Y label. That's pretty straightforward. So that's basically the content of the label. This is the font size, that's 10, and font weight, it could be italic or bold. And the same thing applies for the Y label and the ZM, font size 12, and then bold and things. Title would be done by this. The legend would be basically tell you, show the legend. The location is southeast, which is actually the lower right part, right? So let's just do that and then try to save the files using the command line. So that's where the legend is located. Now we save the file, and I said we basically can save it as a FIG file to be able to show directly from the working directory. But sometimes we simply want to save it as a JPG file or PNG file. What can you do here? Basically is to, there are a few commands to be able to do that. So the first line is to save the current FIG, which is the handle for the figure, to a JPG file named head.png. And the name type, the file type is dpng. So if we run that line, you'll be able to see that head.png file is saved. So can we double click from here? Let's try that. So what we'll do is we open up a direct working directory, and then you will see the head PNG. And this is basically the PNG file that you can put into your report, right? So this is line, so the line thickness, if you really want to make it better, you can actually put the line thickness even thicker. And if you really want to have a grade, you can do that too. So you can see that these lines could be, let's say grade, you can do the grade, but grade is not given in our script. So you can simply do a search from here. Let's say MATLAB plot show grade. And then you would be able to find out a few examples here. Say grade on, that could be the one that might work. So let's try to put it in and see whether it works. And if we do that and go back to the graph, look, this is actually the grade. And you can also increase the line. So basically, just not try to limit yourself to all the things we have provided here. You would have a kind of intuitive feeling that some of the functionality has already been put into the MATLAB, and then it's just a matter of searching, find out the right command to be able to achieve your functionality. And this is usually the way how we communicate with MATLAB. Don't be afraid of doing that. So once you get familiarized of what's being available in MATLAB, it makes your project much more intuitive than the very first project you have it here. So once we've done that, then we could further go the print to a TIF file. So TIF is actually a high resolution JPG, that kind of scalar files. So if you've done that, then you will see the head TIF file in the working directory. So that's the TIF file. So the resolution wasn't refined, so we can change that into 300, and the file resolution would be much better. And if you look at the size of the file, that increased quite a lot, and you see the resolution becomes much better than we tried before. Right, so basically this is the resolution parameter. The other thing is that instead of go to a scalar figure, you can save it as a EPS file, which is actually a vector-based file. And when you do that, you will be able to see the file in this location. So EPS is usually opened up by Adobe Reader. So usually the professional journal publication would require you to put in EPS file because the resolution will not be decreased by further zoom in within the PDF file, which is preferred. So if you look at the file size, it's actually much smaller as compared to the TIF files. Again, you can save the whole thing into a FIG file. So that's basically the command. So it's equivalent to you click File, Save As, and then the FIG file. So rather than using mouse, you can just use this line here to be able to save it into your FIG file. So basically that's how the plotting function is working. The second one differentiates from the first one in the fact that we use subplot. So the plotting area is separated by two parts. Let's try the very first one, and you will get the idea. So you see that the plotting is only at the upper part of the plotting area, and this is because the subplot function. So the subplot function says that split your plotting area in two rows, one column, and the first plot is going to be at the first location, which is the upper part. And that's the reason when you do the plotting later on, it's all at the top section of the plotting area. And if you do later on the one below, they will plot at the lower section of it, because the number 2 here tell you to plot it to the lower part of the plotting area. So if we do that, you will see the result looks like that, right? And we again can save the file to be able to post the processing. So you could either save it as a FIG file where you can double click and do a little bit change of the color, things like that, if you prefer to use the interactive session. And then later on you could save it as JPG file in a similar way like this, right? The other function that I really want to pinpoint here is that you actually can copy and paste the graphs into different plotting area. You want to put the green line to the plotting area here. So how can you do that? What you could do is click that one. So you first click the arrow, and then later on, once the arrow is activated, you can click this line and right click copy. And then you select another plotting area and then do a paste. You will see the graph is actually located to another one. Let's say in some cases when you do two simulations and then the simulation result over time is different and you want to visualize both in one plotting area. So this is a very handy way to copy and paste the graph in among different locations. And the second way basically is to go to your workspace. Let's say here Y1, and then copy those whole area into your spreadsheet and then paste it. So it's all about your preference really, but we just provide those information to you so that whichever is better for you, just go for it. And that makes your plotting a bit more enjoyable. The other two takes from the plotting here is that you could always search the line specification list from MATLAB documentation to find out the right type of lines, the right types of markers, the shapes, and the specific type of color to highlight the graph that you want to display. So always try to use the right one that you would like to use. The second thing, which we are not going to go further detail, is about the 3D plot. So 3D plot could be done either by surface plot, which is more or less like a topography, using a surf function, surf, MATLAB. So if you look at the surf, you basically will need X, Y, and Z. These three properties to show you a surface conditions. The second normal function we use to plot 3D result would be contour, C-O-U-N, contour F, MATLAB. So this is a very popular 3D plot what we normally use, and you can also put in the contour lines and also the labels as well. So for the 3D plot, it's actually quite convenient to plot the 1D partial differential equation result, because the x-axis could be considered as time and the y-axis could be considered as a space. And if you look at the result over the surface, you basically can see all the results straight away from one plot. Finally, we are going to do a exercise. So the exercise is to solve a question here, which is to write a script to see if our input number is a prime number or not. A prime number is the number that can only be divided by 1 and itself without remainders. For example, if we are using number 3 can only be divided by 1 and 3 without any remainders. So number 3 is a prime number. Whereas number 8 could be divided by 1, 8, 2, 4 without remainders, and that's not actually a remainder number, a prime number. So we need to find out the right algorithm to be able to tell any input digit is a prime number or not. So here is a basic flowchart. The first thing is to get the data, the number I from a command prompt. And once the command prompt is put in, we need to use a for loop that loops through number 2 to I minus 1. So if any of these numbers is able to divide I without remainder, we make the conclusion this is not a prime number. So in that case, we basically need to jump out from the loop and then make the conclusion. Whereas if the j keeps going until I minus 1 and still there is remainders after the division, that means that the number we put in here is actually a prime number. So basically this is the algorithm we need to implement through MATLAB. So let's bear that in mind and then try to implement this in the code. So we need to identify the problem one by one. So let's open up a empty editor here and save the file as prime number, right? And then we can basically find out all the key search results to this editor and then later stitch all together to make it as a functional code. So the first thing is actually find out the input number. So you basically are able to put in a number here with a question, and then this number will be accepted by the system. So the way of doing that is basically search again, MATLAB, request input, right? And then you'll be able to find out some useful things. So you request user input, and here has got a useful command that might be the one that we're after. So if we read it carefully, x is equal to input prompt, display the text in prompt, and wait for the user to input the value and press the return key. That's exactly what we're after. So we could even try to use the existing example here. So prompt, x is equal to prompt, and see whether that actually ends up with the value we would like to see. So let's clear everything. And you will see that after running this command, they will ask you that what is the original value. So we can try to put in 10. And then basically 10 is being saved in the variable x, and this is exactly what we're after. So this bit could be saved here as the input. And instead of x, we could put I, which is according to the sketch we have done before. So that's clear. So that first one is finished. The second one is actually loop from 2 to I minus 1 for j. So then we need to write a for loop. So for I is equal to 1, column, and say I minus 1. So here it actually needs to be a j. One more thing you would like to do in some of the cases here is actually using comment here. So we could say comment, this is the for loop, and the comment here will not being executed It's just a comment for your own reference. You could also put this one here, say that's the preparation and input, right? And when you end up with a for loop, you could do an AND. And all the lines in between is going to be looped over from 1 to I minus 1. Now, the key function here we need to search is check the remainder of I divided by j. Is there any existing function that is able to do so? I will probably say yes, because this is a very basic algebra calculation, so it should be available in MATLAB. So in this case, you could search simply MATLAB remainder after division, and you will find something. So remainder after division, so this one is quite close to what we are looking for. So RIM A comma B returns the remainder after division of A by B, where A is the dividend and the B is the divisor. So that's exactly what we're after. So we could give it a try, say REM 5, 2. So the remainder is actually 1. Right? 5 divided by 2. Let's just try to do it again. And the return is actually 1. And that actually means this is to check the remainder after division. So we could put that functions in here too. So here would be, say, check the remainders, right? So we could put remainder is equal to REM I j, right? Now we need to check whether this value, the remainder, is 0 or not. That's basically the if condition. So you will also see that if I didn't put a semicolon, there will be a wave underneath the equal symbol, which suggests you to put a semicolon to suppress the output. You can simply do that to remove the warning here. So now it's about if condition. So if remainder is equal to 0, and what that will do. So when we get the if, the first thing is that we need to get an AND. So that actually finished the if. So if the remainder is 0, that means there is no remainder, and that actually means the we don't have to go further to the next j value anymore, because we've already made the conclusion that the input value I is a prime number, so we don't have to go further. So we need to jump out the loop straight away. Then we need to search a command that is able to jump out the for loop, right? So we can say MATLAB jump out from for loop. And are we able to get something? Terminate execution of the for or while loop. So MATLAB break, and we can read a bit further, say break terminates the execution of a for or while loop. Basically, statement in the loop after the break statement will not execute. So this is actually what we are after. So we could do that as break, right? And if this is the case, then we could have a identifier, say is prime is true or false. So at the very beginning, we could assume that is prime is equal to true, right? And once this bit is completed, then before we jump out of the line, we basically say is prime is equal to false, right? So that basically tells that if we find any of the j here is able to divide I without remainders, we can basically make the conclusion that is prime is false. And then we could basically make a conclusion. So if is prime is equal to false, then we display the result saying that the result is actually false. Else is prime is equal to, say, is prime. Else is actually is prime to true. So basically is to display the result as true, right? Display the result as false. Okay, so, and if we got another if condition, then we need to end, right? So we need to find out the right command to be able to display the result. So we just have a further search again. So search MATLAB display on command line. We've done that just now, so we basically emphasize here and do another search. So here has got this one and that one, so we could do that one here. So we could say FPN, this is not a prime, and here we can say prime. Give it a go, okay? I think it's pretty much ready. And then we can try to run the whole script and then say what's the original value. Oh, we haven't changed the sentence, but we can do that later. So if it's 10, is prime is true. So this true here actually I believe is the true and false is accepted. We could try that again. No, so in that case we can put true as simply 1 and false as 0. Right, so false is 0, which serve in the same way. And then we can do that again. 10 is not a prime. And if it's 5, 5 is not a prime. Why is that? So we find out there is a bug. There is a bug. I think the bug, if we search it carefully, is that the for loop here starts from 1 rather than 2, and 1 can always divide the value without remainders. So that's actually where the problem comes. So we can try that again and then say number 5, that's the prime, that's great. And we can try 10 again, and 10 is not a prime. This is basically a quick test to see whether the program actually works or not. And there's quite a lot of ways you can further improve the program if you want to. One of the way is to reduce the number of loop here. So as you can see that if we've got a number of, let's say, input number as 11, basically half of 11 is good enough to make a conclusion. So we basically just check half of the whole thing. So in that case, we can change this value to half of the I, right? And we could, because if we do that, then there is a chance that the I value is, this value here is the half. So we want to check the upper part of the half, then we could use a command called roof, right? So by doing this, the number of loops within the for loop will be reduced almost like half to the case that we had before. So this is the way that we can further improve it. So we can try number 7. This one, okay, so it's not roof, it's actually seal, I think. So number 7 here, so that's a prime number. And we could try, let's say 97, and that's a prime number. And it has already gone through quite a lot of things here. The second thing what you could do is that you could simply use the J as your indicator. So as you can see that when you jump out from the for loop here, the J number is not going to be this value at all, right? So in that case, you don't need to use a prime at all. So what we can do here is we first save this file into another file, say save as version 2, right? So we could say that once it jumps out of the loop, usually the J is less than that value. So what we could do is that we don't do a is prime. We basically use J to check the result. So at this point, if J is not equal to seal half, this is not a prime. Else, this is going to be a prime. So if we run by this way, we actually save a space in our program to run the whole script. And we can try to do the same thing again and see whether this one works. So let's say number 6, this is not a prime. And we could further try, let's say number 7, and that's the prime. So as you can see that we basically can further improve the code by make it more compact, declare relatively less variables if you really keen to do so. But remember, as we discussed before, your time is much more important than computer time. So if you are able to run a program with relatively more number of variables, just go for it. That's not really a problem. The example here shows that you have multiple ways to achieve the same goal. Whatever type of method you have used, the goal is basically to make the code functional, and you have multiple ways to go there. The final thing I want to show here is basically a comparison of the code between your previous examples and your current example. So in programming development, we always try to implement code in a step-by-step manner, which means that we try to achieve some milestone and save it to another file, and then later on you try to create another file on top with more functionality. And if the new attempt is failed, you can always try to roll back to the previous version. And also, you could simply compare the code in between each other. MATLAB has got a good comparison functionality into the script here. The way how you can compare the code is basically go to the editor here and then find out the underscore here, compare, and then save and compare with. And basically the prime number version 2 is here, and then you can do another one, say the prime number, right? That's the second one, and then we do a compare. And after this, you'll be able to see exactly in which line that is identical and which line that are not identical. So just in case, if you have done several versions, you could always use this function to identify where is being changed exactly, and that could help you find out your errors inside the code. So very useful tool that I believe you will be using it down the track in your project. Okay, final thing. We want to discuss a few points when doing programming. First of all, MATLAB is case sensitive. So if it's a case sensitive code, you need to make sure that all the variables has got exactly the same pattern. If it's capitaled, then you need to capitalize all the way down the track so that you wouldn't spend too much time to find out where your bug is. Perhaps you define a capital and another one without capital, and the value doesn't pass on, and then that will have the problem. I think in general you can follow two ways. One is camel cap, like this way. So this is my name. So that's basically one way to name your variable, and you always use that way. The second is underscore, so it's basically like this. So then everything is not capital, is underscore my name. So that's pretty straightforward for you to name your variable. So you could use either camel cap or underscore. The second is the clear indentation. As you can see that we use for loops and use the if condition quite often. And if you use the indentation very clearly, the code speaks for yourself. They know that which bit of code is subordinate for what type of condition. And if you basically see your code clearly just by looking at it, the bug has nowhere to hide. I would suggest you always use clear indentation when you use if condition or subordinate statements. And you could just simply put 4 spaces to make an indentation, and that will make your code last for long as well. Number 3, ensure the units are consistent in all the variables in the program. SI units are always preferred. Well, I have to emphasize that 90% of the error or the bugs we have experienced so far in our course is related to units. The project comes with different variables, and the variable has the unit, and I think the best way to start with them into the code is to convert them into SI unit. And once you do that in the SI unit, you can basically forget about unit conversion within your program. And you could use grams or centimeter square and centimeter thing, this kind of thing, but then you have to use it consistently. You really need to get the unit conversion complete in the initialization session. Never do it during the loops. So once you got the initialization part, the unit conversion is solved. And don't look them again when you are doing the calculations. And that makes the situation very, very complicated. The loops basically is the place you try to solve the problem rather than convert your unit. If you try to do the conversion, I've seen quite often people use 9.81, 1000, 3600, this kind of numbers. And what I'll tell you is that when you do the conversion, those number makes fully sense. But the problem really comes that every single time you try to check the unit conversion, you have to do it again. Say time 24 times 6. And later on, this one doesn't make sense. So actually, are you trying to convert second into minute? It doesn't tell yourself. What you could potentially do here is that you name the variable to time second. And then this one is hour per second. So you can basically look at this as a unit. Second is in denominator and hours in the numerator. And then after the conversion, obviously your time is going to be in hours. So this will help your code to be readable all the way down the track, even 5 years after. And the fourth point is that you try to use variables that are physically meaningful. So as you can see the examples, we use A, B, C, and temp quite often, but those should be avoided for your project code, because over time, those A, B, and C doesn't make sense. It's only at the time when you use it, and once you don't use it, later on they will lose their meanings. The second way of name the variable would be using their algebra variable, so row or KWA, and those are usually the name we put into the equation. And this variable is completely okay. Third one, which is the way that I normally do, it's to call density water kg per meter cube. Conductance between water and air, water per meter square per second. The reason I really like that is because when you do the calculations in between those variables, the unit is balanced. You basically do the unit conversion at the same time. The second interesting thing I'll tell you is that once you use variable like this way, you don't have to look at the equations again. If you use this one, you have to go back to the equation and see, perhaps the equation looks like that. But if you do this, it will be completely meaningful even without looking at the equation. That's basically the most of the time I'm using my variable. So even though it's relatively long, but the name just explains itself, and I really love it. We've been started using MATLAB. I think at the very beginning you might get scared. So, this is a very large library with so many functions. Are we able to cope with it? And do we need to basically find out all the commands, go through all the possible functions before we start any projects? No. The best way is basically learning it by working on the project and solve problems. It's similar to learning another language. So the best way of learning it is to speak it rather than go through all the dictionary. And if you need to know a new command, just search as what we normally do in our demonstration here, and never being scared and try to find something. And maybe those commands has already been implemented internally, and prime number maybe has already been implemented so that you don't have to create this function by yourself. So try to solve the problem and keep on searching to find out the solution for you, and this is the best way of learning it. So at the beginning you might be afraid that it might take longer time to solve the problem, but over time you will become very proficient, and then solve the problem could be quite straightforward. The last one in this page is that debug may take 3 times more than the model constructions. This is very, very common. So a lot of people would say, I understand the governing equation and I implement the governing equation into the MATLAB script, but it doesn't work. Did I get any credit? No, because if your code doesn't work, that means the implementation was not successful. So I would still advise you to find out your bugs, and there must be a bug to stop the code from working. There are a few ways for you to avoid the debugging time. First tip is that implementing function in a step-step manner rather than implementing all the function one-off. So I can guarantee you, if you try to put all your functionality into a script and click run and expecting that everything will be fully fledged, that will never happen. The best way is actually doing step by step. Let's say if you have got 2 equations to solve, they are able to be solved one by one. You can put in just one and then check it. Well, if it's working, then go for another one. So never try to implement everything inside, and that wouldn't work. The second thing is that you always back up the successful simulation run and programs. So as we discussed, you can save the M file. You can also save the variables by saving it as a MAT file, and you can back visit it. And if you save the backup, you can safely go for the next adventure, and maybe the next adventure is completely failed. You can just simply roll back to the previous successful case, or even use the compare functionality to see potentially where has produced the new error. The number 3 tips is that be patient on finding logical errors. So a lot of the time when the program report wrong, the wrong point is not actually at the location where the error has been reported. Let's say some of the examples, if you use the square root and a negative value into the square root, and you end up with a imaginary number, and the imaginary number will be stay in your variable, but eventually once it calculates some new values, they will produce an error. So the error is not actually the location where you use square root to calculate a negative value. So in this case, you really need to check carefully line by line to find out where potentially error is. I would suggest you to ask your buddy to check your code rather than yourself, because once you're checking over and over, you tend to follow the same pattern rather than thinking out of the box, Whereas if you have a buddy sitting next to you, he or she might put in different views, and those views would divert your attention or find out something you took it for granted, and then the error will come up. The number 4 tips here is to use coding comparing tool to compare your new code with previous benchmark codes. So that's been discussed already. You always use that comparing tool to see maybe you mistakenly input one wrong variable and that makes the code wrong. So always use the compare way to find out where the bug is. The last one is that to use better math to reduce the number of the brackets in the code. So it's very, very common for us to see so many number of brackets inside one line of commands. You really need to make sure that the code basically speaks itself. So even by eyes, you are able to see which part is in the numerator and which part is in denominator. And that actually helps you to make your code clean and there is no space to have any bugs. We are here to help. I hope that you can learn how to construct your code and how to debug the code, and I can tell you that the moment when you find your bugs is actually the moment you feel it's very rewarding and you feel more confident in programming or solving problems use programming tools. And good luck for your programming. Thank you very much.